Gravity is not just a physical force, but one of the keys to understanding the deepest mysteries of the universe. It governs the birth, evolution, and end of stars, shapes the structure of galaxies, and determines the ultimate fate of the cosmos. However, despite its evident presence in our daily lives and the macrocosm, it remains one of the least understood forces in modern physics. After the Big Bang, which occurred about 13.8 billion years ago, the universe was a rapidly expanding soup of elementary particles. Initially, the temperature and energy were so high that the four fundamental forces of nature, gravity, electromagnetism, the strong nuclear force, and the weak nuclear force, were indistinguishable. However, as the universe cooled, these forces separated, and gravity began to act, attracting matter and allowing the formation of the first cosmic structures. Thanks to gravity, enormous clouds of primordial gas collapsed in on themselves, giving birth to the first stars. These, in turn, clustered into star formations and galaxies, shaping the universe as we know it today. Gravity not only enabled the birth of stars and planets, but is also responsible for the formation of exotic objects such as neutron stars and black holes. Among the most mysterious and fascinating entities in the universe, black holes represent the ultimate limit of gravity. When a massive star exhausts its nuclear fuel, it can no longer withstand the pressure of its own mass and collapses under gravity's force, creating a region of spacetime where the gravitational pull is so intense that nothing can escape, not even light. The event horizon of a black hole marks the point of no return. Everything that crosses it is inevitably drawn toward the central singularity, a point where density becomes infinite and the known laws of physics cease to function. According to general relativity, inside a black hole, time itself slows down and ultimately stops, creating a rift in the fabric of the universe. But black holes are not just devourers of matter. Recent studies suggest they could also be incredibly efficient energy generators, thanks to the accretion disks of matter orbiting them, which heat up to extreme temperatures. Furthermore, gravitational waves discovered in 2015 through the LIGO and Virgo instruments have allowed us to detect black hole mergers, offering a new observational window into the universe. One of the most intriguing enigmas of modern cosmology is the presence of dark matter, a form of matter that neither emits nor absorbs light, but reveals itself through its gravitational effects. Observations of galaxies indicate that they rotate too fast for the amount of visible matter alone. Without an additional source of gravity, the outermost stars should be flung into intergalactic space. Dark matter is thought to constitute about 85% of the universe's total matter, yet its nature remains unknown. Some theories suggest it is composed of yet undetected particles, such as WIMPs, weakly interacting massive particles, or axions. However, more radical hypotheses propose that our understanding of gravity is incomplete, and that a new theory is needed to explain these effects on a cosmic scale. If dark matter represents the invisible side of gravity, dark energy is its even more mysterious counterpart. In the 1990s, astronomers discovered that the universe's expansion is not slowing down, as one would expect due to gravity, but is actually accelerating. This accelerated expansion suggests the existence of a repulsive force counteracting gravity on cosmological scales, dark energy. According to current estimates, dark energy constitutes about 68% of the universe and could determine its ultimate fate. If expansion continues to accelerate, in a distant future, the universe could undergo a phenomenon known as the Big Rip, where the force of expansion would surpass gravity and the other fundamental forces, leading to the disintegration of galaxies, planets, and even atoms. If gravity is so fundamental, is it possible to manipulate it? Until today, all our technologies have been based on controlling the other three fundamental forces, but not gravity. However, some speculative theories suggest that it might be possible to alter its effects. One of the most fascinating ideas is that of gravitational engines, hypothetical devices that would harness gravity to generate energy or propulsion. Some quantum physics theories suggest that gravity could be mediated by particles called gravitons, whose existence, however, has not yet been experimentally confirmed. If gravitons could be manipulated, we might one day create artificial gravitational fields, paving the way for revolutionary technologies such as gravitational levitation or fuel-free interstellar propulsion. Another intriguing hypothesis is the use of wormholes or Einstein-Rosen bridges as shortcuts for traveling across the universe. If gravity is a curvature of space-time, then it might be possible to bend space in a way that connects two distant points through a gravitational tunnel. Although this idea remains in the realm of science fiction for now, some mathematical solutions in general relativity suggest that such structures could exist, though they would require a form of matter with negative energy to remain stable. From Newton to Einstein to modern quantum theories, our journey to understand gravity has spanned centuries of discoveries and scientific revolutions. Yet many questions remain open. Can gravity be unified with quantum mechanics? Do gravitational particles like gravitons exist? Are dark matter and dark energy real physical entities? Or do we need to rewrite our theory of gravity? Will we one day control gravity to travel through space or revolutionize technology? Gravity is much more than just a force. It is the invisible thread that holds the universe together, the architect of galaxies, the engine of cosmic destiny. Perhaps one day, thanks to advances in physics, we will master it and open new frontiers for humanity. Thanks for watching. Leave a like and subscribe to the channel so you don't miss future videos.